So 5 over x squared plus 1, 2 minus x plus a fraction. So I've got a quadratic term and I've got a linear term. So over the quadratic, it's going to be ax plus b. And then over the linear, it's another constant. So the next step is c over 2 minus x. Multiply through by the bottom line. So that's going to give me 5 equals x squared plus 1, 2 minus x times this expression. So 5, right, they cancel out, so that's 2 minus x ax plus b plus c. The 2 minus x is cancelled out, so that's x squared plus 1. So I can make the bracket 0 by putting x equal to 2. So put x equal to 2, and I get 5 equals, this is all 0, that's c bracket, 2 squared is 4 and 1 is 5, so 5c is 5, so c is 1. Okay, the next value we're going to pick is 0, so I'll take out the a. So x equals 0, so that's 5 equals, 2 minus 0 is 2, so that's 2 outside the bracket. X is 0, that's gone, so that's 2b, 0 in there, plus c. So c has a value of 1, so that's 5 equals 2b plus 1. So 2b is equal to 4, so b is 2. I need one more value of x going in. So I suppose the next easiest value to pick is 1. So x equals 1, so that's 5 on the left. Putting 1 in there, 2 take away 1 is 1, so that's 1 times that bracket. And 1a, so that's a plus b. And 1 in here, 1 squared is 1 and 1 is 2, so that's plus 2c. So 5 is a plus b, which is 2, c is 1, so that's plus 2. So a plus 4 is 5, so a equals 1. So 5 over x squared plus 1 times 2 minus x equals ax plus b. So a is 1, so it's 1x, that's x, plus b is 2 over x squared plus 1, plus c, which is 1 over 2 minus x. So that's part A. Part B says using the substitution u equals tan x and the result in a. Right, so whatever I've done in a is going to somehow link to my part B then. I need to evaluate this integral. So at the moment I'm going to integral from x is 0 to pi by 4 of 5 over 2 minus tan x dx. My substitution is u equals tan x. Right, limits first of all then. So if x equals 0, u is the tan of 0, which is 0. If x is pi by 4, u is the tan of pi by 4. Tan of pi by 4 is 1. So there's the limits. Now I need to deal with the dx. So u is tan x, differentiate that. du by dx is sec squared x. So du is equal to sec squared x dx. And this needs to go in terms of u. There's no sec squared there, so I can't use it there. Now if u is tan x, then u squared is tan squared x. I know that 1 plus tan squared x is sec squared x. So tan squared is u squared, so that's 1 plus u squared is equal to sec squared x. So du then is 1 plus u squared dx, or du over 1 plus u squared is equal to dx. So I'm now ready to substitute in this integral then. So it's now going to become the integral. So 0 to pi by 4 will go 0 to 1. 5 dx is du over 1 plus u squared all over 2 minus tan x, which is 2 minus u. Okay, so integral from 0 to 1. Right, if I take the excuse me, if I take the 5 out, so that would be du over 1 plus u squared 2 minus u, and there's my u integration. Now it told me to look at part A, link it to part A. Okay, well in part A I rewrote this expression, and if you look at that expression to what's there, I'm going to take the 5 back in the integral now because there's a 5 there. Okay, it's the same as the integral from 0 to 1 of 5 du over 1 plus u squared 2 minus u. So this expression here is the same as that. Okay, so this integral then is going to be the same as the integral from 0 to 1 of u plus 2 over u squared plus 1 plus 1 over 2 minus u du. So the first, I've got two terms on the top here, so I need to break those off first of all. So it's the integral from 0 to 1 of u over u squared plus 1 plus 2 over u squared plus 1 plus 1 over 2 minus u du. So there's the three terms. So this one, okay, if you note, I can't use a standard integral here because there's a u term on top. However, if I differentiate the bottom line, u squared plus 1, if I differentiate that, I get 2u. So rewriting this one will go same as a half integral from 0 to 1 of 2u over u squared plus 1. So if I get the derivative of the bottom on the top, that's log of the bottom line, plus twice the integral from 0 to 1 over u squared plus 1 du, and that's a standard integral. That's on page 5 in the formula booklet. That's the tan to the minus 1 integral plus the integral from 0 to 1 over 2 minus u du, and that's a linear term on the bottom, so that's going to be a log. So this is a half ln u squared plus 1 for the first term from 0 to 1, plus this one is twice tan to the minus 1 of u 0 to 1, and this one is log of the bottom line, but it's a if I differentiate the bottom line again, minus 1, so that's minus ln of 2 minus u from 0 to 1. So now I just need to sub these values in and calculate them. So that's a half ln of 1 squared plus 1, so that's 1 and 1, that's log 2, minus a half ln u is 0, that's ln of 1, plus 2 tan to the minus 1 of 1, minus 2 tan to the minus 1 of 0, minus log of 2 minus 1 is 1, minus ln of 2. So log of 1 is 0, that's 0. Tan to the minus 1 0 is 0. Log of 1 is 0. So the calculations I'm doing then is half log 2 plus 2 tan to the minus 1 of 1 plus log 2. If I type that in the calculator, remember I'm in rad mode here for that one, that will give me 2.61. The three significant figures.